Hey guys, today we're going to be looking at the theory of plate tectonics. So go ahead and set up page 8 in your notebook to look like this. Title it, What is Plate Tectonics? And in the margin of page 8, write today's essential question, what is plate tectonics? So we've looked at continental drift and how Alfred Wegener came up with this theory that the continents have drifted to their current locations. They were all one giant continent called Pangaea, and they've since drifted to their current location. And a lot of you guys were asking, well, how is it that they have moved? Well, the theory of plate tectonics answers that question. So, plate tectonics, we're going to write this down on page 8. Is the theory that Earth's crust, remember that's the outside layer of the Earth, the Earth's crust is broken into large moving pieces called tectonic plates. So that's the theory that the Earth's crust is broken into large moving pieces called tectonic plates. Now, those plates are what is moving. So when we say that the continents are drifting, those continents are located on tectonic plates, and the plates are what is moving. So those plates move because convection currents in the mantle. So convection currents in the mantle move the plates. So that's how we see tectonic plates moving. That's how continental drift occurred. There is convection in the mantle. Remember, that's the layer underneath the crust. Convection in the mantle is what moves those plates. So remember, we reviewed convection where the hot rises and the cool sinks. So we're going to look a little more closely at that in just a second. I want you to think about Earth's crust, though. That is the outer layer of our planet. And Earth's crust, when we're talking about tectonic plates, we're going to notice that there are two types of crust. So we have oceanic crust and continental crust. So we're going to make a little chart here. Remember to save some space at the bottom of your page for your diagram that you have. We're going to divide it into two columns here. So when we look at oceanic crust, this is crust that is found under the ocean. So this is like the ocean floor. The ocean floor is made of oceanic crust. Oceanic crust is younger in age, so it's newer. So we can put / newer. It is thinner, and it is also more dense. And more dense, remember, means that it is heavier. If we look at continental crust is found on land. So that would be all land as part of continental crust. Continental crust is older. It is thicker. And it is less dense. Now that might not make a lot of sense to you. If it's less dense or lighter, how is it that it's thicker? Well, when we're talking about the density of oceanic crust and continental crust, we're looking at the rock that composes each of those crusts. So the rock that makes up oceanic crust naturally is just heavier. So it's gonna be more dense. The rock that makes up continental crust is lighter naturally. It's lighter, so it's gonna be less dense. Let's take a look at that picture that you have, that diagram. So it looks like this, and I'm going to zoom in just a little bit here. So what we're going to do is we're going to label some things and kind of show how it is that these tectonic plates are actually moving, okay? So if we look at this, on the right-hand side here, this is our continental crust. So remember, continental crust is thicker, so you can see that in this picture. And then over here we have our oceanic crust. So it is going to be thinner. Notice that your oceanic crust look like it's kind of going underneath this continental crust. So remember that oceanic crust is heavier, it's more dense, so that when it meets that continental crust, it's going to sink underneath it. And we'll talk more about that later in this unit. We can label our ocean here. Where is it that where would we find the heat source of the Earth, or inside of the Earth? Yeah, that would be in the core. So right here, I'm going to write heat from core, and I can draw maybe some little squiggly lines here to remind me that the core is heating up the Earth, right, from the inside. And that heat from the inside is creating that molten rock that we see in the mantle, the magma, okay? So what happens is that heat from the core heats up this magma, so that magma is warm. It rises because it's less dense. And as that magma gets to the upper part of the mantle towards the crust, it's going to start to cool off. Now remember, it's still going to be very hot, but it's going to be cooler than the surrounding areas. So the warm magma rises, the cool magma sinks. So over here we can label the same thing. The warm magma rises, the cool magma sinks. And that specifically is how tectonic plates move.